and welcome back to
The Bio Show with
Amanda
and Teijah. On today's episode, we're talking about ketamine!
Do you know what ketamine is? That's right. Ketamine is a drug primarily used in the 1960s as an anesthetic.
Also known as a club drug in the 1980s, and recently, in the last few decades, as a treatment for patients with treatment-resistant depression.
Ketamine has a therapeutic effect in terms of the restoration of frontal control and contributes to the decrease in depressive symptoms.
But it also improves emotional regulation by making a more balanced interaction between the prefrontal cortex, also known as the PFC, and the deeper limbic structures, result in improved regulation of mood.
For example, before ketamine treatment, an individual with depression might have heightened emotional responses, which are driven by the limbic structures.
And after ketamine treatment, there could be a rebalancing, with the PFC gaining enhanced control over emotional processing.
This manifests in less severe depressive symptoms.
Ketamine induces disassociation and emotional blunting, which can be beneficial because it provides relief from aversive emotional states associated with depression.
This is due to the impact of the neurotransmitters, more specifically to the modulation of the amygdala during the glutamate transmission.
And to further your knowledge, we prepared a visual presentation. Let's go! It's important to note that the effects occur rapidly within a few hours or days. According to Lonsku et al., 50% of TDR patients report a decrease in symptoms within 24 hours. Now onto the mechanism of action in the adult brain.
The mechanism of action of ketamine is primarily based on how it acts as an antagonist to the NMDA receptor. An NMDA receptor is an ion channel and a glutamate receptor.
In fact, it ramps up the production of glutamate, which means that it disrupts glutamate transmissions. Glutamate is a key excitatory neurotransmitter in learning and memory. There's an altered communication between nerve cells.
Beyond NMDA receptors, ketamine interacts with neurotransmitter systems, including dopamine and serotonin,
causing psychotropic effects, which involve alterations in mood, perception, and consciousness.
Let's talk about the influence of ketamine on brain functions.
Ketamine has a noticeable effect on specific areas of the brain associated with mood and cognition.
Following Salvana and Kwan, ketamine rapidly alleviates depression by modulating the hyperactive response of the subgenual anterior cingulate cortex during transitions away from depressive states.
And in the posterior cingulate cortex, PCC for short, there's an altered activation indicating changes in self-awareness and reflective processes.
As mentioned before, this also affects the PFC.
And in the hippocampus, changes are observed, hinting to potential alterations in memory and learning functions.
Hey, it's nice to see you again. Let's jump back into talking about ketamine.
There's a noticeable lack of studies addressing the long-term safety of ketamine, particularly in the context of ketamine-induced cystitis relating to depression treatment.
Ketamine-induced cystitis includes symptoms of dysuria, which is discomfort during urination, urinary frequency, and urge incontinence.
In a few studies, it is suggested that urological complications only affect 10% of cases.
Still, significant unknowns persist regarding the long-term effect of ketamine, which should be addressed by the scientific community.
Oh, would you look at the time? We'll have to see you again next week.
Bye!